Hey everyone, we're going to continue talking about variation. We talked about spread in terms of standard deviation, and that was convenient because we can assign a single number to it. But there are other ways to talk about variation. And I'm going to give you an example you're probably familiar with, at least I was when I was in high school. Let's say you get your test back, your math test back, and you look at it, you open it up, and you get like a 60. And then you're thinking, oh my God, how am I going to explain this to my parents? And then you ask your friends what they got on the test. And then like everyone did poorly. So you go home and you're like, tell your mom, oh my God, I got a 60 on the test. But then you're like, but mom, like half the class got between a 60 and a 70, right? Or like most of the class got between a 55 and a 75 or something like that. When you say that, you're talking about the variation in test scores in the class, right? You're talking about like that middle group that like most of the class got in that area. Now there's always that kid that got like 100 because he always gets 100, or the kid that never pays attention and got the 0 in the class. You're not talking about them, you're talking about most of the class. Well, that's what we're going to do today. We're going to kind of talk about that middle chunk a little bit. And the way we're going to do it is we're going to use something called quartiles and the interquartile range. Those two things are going to describe the situation I was talking about. These other two concepts, the 5-number summary and the box plots, will be a natural sort of continuation of that. So let's take a look. So let's start with this idea of the interquartile range. First of all, we have to talk about what a quartile is. So there's this dot plot at the bottom. Doesn't matter what the data is about. But what we're going to effectively do is we're going to chop up the data into quarters, hence the word quartiles. We're going to make 3 groups. So we start by cutting it in half. And we all know that when we cut the data in half, we're actually finding the median. Now, to cut it into quarters, we take each half and cut it in half. We call one of them the first quartile and the other one the third quartile. So you'll see that these 3 walls, if you will, chop up the data into 4 equal pieces. It won't always be perfectly equal because you can have an odd number or something, but the idea is the same. The first quartile is bigger than 25% of the data, right? So that's the first 25. The median is bigger than 50% of the data. The third quartile is bigger than 75% of the data. But that's what quartiles are. They chop it up into 4 sort of like buckets. Now, that middle bunch of students that you were telling your mom about, we call that the interquartile range. It's the distance from Q1 to Q3. Mathematically, we just subtract Q3 minus Q1, and we get a number. And that number is the interquartile range. It describes how wide the middle 50% of the values is. Unfortunately, it doesn't tell you where it is, right? It doesn't tell you where the numbers are. So in this particular example, I don't know, it looks like about the interquartile range is about like 32 and change minus 23 and change. Maybe it's about 9. So we're going to look at some more examples. Let's take this data set. So we have 20 New Yorkers. These are their travel times. And let's find the interquartile range. The first thing we need to do in order to find the median is, of course, put the data in order from lowest to highest. Then we can find the median by looking at the middle 2 numbers and averaging them. But also, we can find the quartiles by finding the middle of the top half and the middle of the bottom half. So, right? Maybe if I need to go back, maybe I'll go back for a second to show you how that's done. It turns out that the median is right. Let me change my, really? There we go. Clear, and let's go back to here. Okay, sorry about that. So it turns out the median is right here at 22.5. If I'm going to find the first quartile, I do my little canceling thing. cancel from both sides, boom, boom. And it turns out that there are two middle numbers, so the average of those two, which happens to be 15, is Q1. Likewise on the top half. Here, the middle is Q3. And of course, this is the median. Okay, so hope that made sense. So we get those numbers. And now we're ready to find the interquartile range. It's quite easy. You just subtract Q3 minus Q1, and you find the interquartile range is 27.5 minutes, right? It has the same units as the original data, of course. And that's the IQR. So there's another very important use for the IQR, just to describe how wide that middle half of the data is. Right, well, sorry, there's the interpretation. But there is another use for it, right? It can help us identify outliers using a mathematical rule. And it's really, really handy. We use the interquartile range as sort of like our ruler. We extend it by about 50%. And we measure from Q1 to the left and from Q3 to the right. All right. So that probably made very little sense. Now you're going to see what that looks like. Here's another set of data. Right. These are fuel economy ratings for a bunch of Toyotas as tested by the EPA, and the results are in the box. The dot plot shows the range. And then you're like, holy cow, wait a second. This one's really low. This one's really high. Are they outliers? Well, what we can do is we can find the IQR and test. So here's the process. The interquartile range is 0.4, right? It's the difference of these two things right here. So 1.5 times the IQR is 1.5 times 0.4, which is 0.6. All right. So what's actually happening here is what we're doing is we're taking Q1 and subtracting that 0.6 and getting 21.6, right? Which is about here. Now, what does that tell us? It tells us that anything to the left of there, we should regard as an outlier. It's sort of the cutoff. Anything to the left of 21.6 is probably an outlier. And just to clarify, here's Q1, right? And the distance from here to here is that 1.5 times the IQR, which in this case is 0.6. Right, so you go from Q1 to the left. Okay, likewise, on the high end, we would find Q3, which we said is 22.6, which is there, and go 0.6 of the way to this direction, and we get this wall over here. So, oops. Oh, I'm sorry, I didn't draw it in the right place. Anything to the right of that purple line is an outlier. So the math is actually very simple. It's arithmetic. But it gives us an idea of how to say what's an outlier and what's not. Mathematically speaking, technically, there is no real definition of outlier. But this is kind of the rule we just use in our class. All right. So in this case, in this set of data, there are two outliers, according to our formula. So why do we care about outliers? We talked about this a little bit in class. They may be mistakes, right? Maybe somebody typed something in wrong. Maybe it's an extreme. Maybe there is something unusual about that car when it was tested. Maybe we should look at it. And we have to be careful because we know that certain measures are very sensitive to outliers. They're not resistant. So you got to watch out for outliers. Okay. Now, this is related, okay? once we have Q1 and Q3, there's actually a graph that we can make that not only shows us the IQR, the interquartile range, but kind of shows us where all the data sort of is. It's a dot plot is useful, but if there are a lot of dots, it's not always clear, where does the middle 50% of the dots lie? Or, where is the median? Where is Q1? It's not clear from just dots. So there's this idea of a box plot. It's also called a box and whisker plot. I'll show you why soon. The first thing we do is we find something called the 5-number summary. And it's easy, right? We already know how to find the median. Yay. We know how to find Q1, we just learned, and Q3. Okay, we know how to do all those things. The other two numbers in the 5-number summary are the lowest and the highest. Easy. That is the 5-number summary. Your calculator will spit this out for you also in one step. I'll show you how to do that another time. Going on. So this box plot is a visual representation, like I said. And this is how to make a box plot. Follow these steps. Okay, these steps are critical that you follow them. Not only follow them, but in this order. All right, first, find the 5-number summary. All right, you find those 5 numbers. Yay. Then, you have to determine if there are outliers. That's actually going to change what your box plot looks like, and you'll see why soon. All right, so once you determine that those things are outliers, all right, you go to the next step. Okay. Sorry, those are outliers, right? All right, so now is when you actually start drawing. Do not skip this step. Do this first. Make a horizontal axis and label it with units that make sense, right? Don't just go from 0 to 100 or whatever. In this case, we're talking about very specific numbers. Just get the numbers down. Make sure you go from at least the minimum to at least the maximum. Then you draw a box right around Q1 and Q3. This is the box in the word box plot. It's the box that actually contains the middle 50%, right? Remember, Q1 and Q3 are helped to chop it up into 4 groups. Between Q1 and Q3 are the 2 middle groups. That's actually 50% of the data. And then next, put the median in there. Just draw a line there, and that's the median. And then you draw the whiskers, right? That's why I said box and whisker plot. The whiskers are going to be 2 little whiskers, one on either side of the box. Now, where do you stop the whiskers? You go all the way to the min and the max, unless the min and or the max are outliers, in which case they aren't part of the whiskers. Okay, so in most cases, they will be part of the whiskers will go to the max and the min, unless those 2 are outliers, or any of them are outliers. And those are the whiskers. And then you do have to show the outliers, and you show them as dots. Some programs show it as asterisks or stars. It doesn't matter. It's the same idea. And that, my friends, is a box plot. And it's not that hard to draw, but it does tell you sort of where the data are. Remember, we don't know specific data points. I mean, we do sort of know, but dot plots do tell us data. Box and whiskers don't. They don't show us gaps. They don't show us clusters. They don't show it's unimodal, bimodal. We will learn that you can actually see skewness and symmetry in there, but not today. And that's about it. I hope that was helpful. Bye, everyone.